How's it going? This is Dr. Schulman. This is going to be the last, I guess, notes video for our curriculum. We will be doing making connections, which not only is part of the NCTM, which is National um, Council of Teacher of Mathematics, like main standard of making connections, but I think it's probably the most relevant thing we can do for our students. So I'm going to share my screen and I'm going to start explaining some stuff. We're here, Math for Teachers, and I'm gonna combine these two, so I don't have to redo them, and I'm just put them all into one for everything. And we're up to making connections. Now, I've said this before that making connections is probably like the most important thing that we're gonna see. So, anything, no matter what it is, I don't care if it's 3x squared minus 2x plus 1, right? Or if it's 5x equals 12, or if it's a shape, right? Like if we have a triangular shape, right? No matter what it is, we can have it represent whatever we like. So I'll pull up some Desmos on the side, just so we have a little bit of something to help us out with this. So I just made this one up, 3x squared minus 2x plus 1, right? This could be the acceleration of something. It could measure, it could model a change over time. You know, it could represent whatever we needed to. The mathematics itself is just used as kind of like a placeholder to help us represent things. The 5x equals 12, like we know it's an answer, it's a specific answer. It's this line, it's just 2.4, but what does that represent? It could be whatever we want. The same thing with this triangle, right? The triangle can be a ladder, right? The this curve right here can be a what? This could be a roller coaster, right? We can literally use these things to represent lots of pieces for us. I know I have this transformations piece that I've used a lot. And with roller coasters, I was just seeing if I could find it real fast, but where I have like roller coasters superimposed, I'll see if it comes right up. If it doesn't, that's okay. I'll look for something else. But I'll put it in after. But yeah, so I have it where all of the parabolas are uh are set as different they're just set as different pieces. I'm just seeing if I can find it real fast. Here's one. Yeah, so we could have the roller coasters being here for our parabolas. We could have this Ferris wheel represent the radians for people. Like all this stuff is just really helpful for students to kind of like see how it works. I have these usually broken down with a bunch of transformation rules for parabolas. So it's like there's definitely ways that we can sorry. There's definitely ways we can do this where the students will really see the connections to other pieces. But this is where you can come in and you can find out more about your students. Like use student surveys and just really figure out what do they like. I've made tons of soccer lessons. I showed you the conversion one, but on top of that conversion one, I'm just seeing what else is over here. Okay. On top of the, I think it was called Spot the Ball. Yeah, so I just want to show you like a more quick connection you can make for students. So this was that one that I showed you before. This is mimicking, where are you, soccer ball? All right. So I had them just write, I know it's kinesthetic, but they wrote a bunch of imperfect square roots on a giant inflatable soccer ball. They threw it around, and wherever they caught it, that would be the problem we did. So we used it as like a number generator. So basically, the connections you can make it to what your students are excited about, what they're interested in. You could have it represent real life pieces, but these connections you can make all over the place. So you can do a survey, find out what students like, or you can just observe them. When my students are always grabbing for their earbuds, when they're grabbing for their earbuds, the first thing that I do is like, okay, I should make some lessons about music. So I made, uh, let's see if it's in this one. Okay, it's on this one. But I'll show you what I'm talking about for the lyrics. So if all my students are interested in music, I would give them a project like this one where they got to pick two different songs they like, and figure out the lyrics of the song, and use that to do a complex analysis of the lyrics to see which one was more lyrically complex. And every word in the song became one of the numbers for them. Then my students had to find the mean, median, mode, all the pieces to it, and then do the BPM of the song and do conversions. They're using songs, making connections to things they like, and they can make a hypothesis about which one's more complex. So I think that's really useful for students when they're making these kinds of connections. And you will see all of these lessons. I'm going to probably do a lot of them here. So if they like art, the end of this one, they got to draw a picture. So they pick an image, they draw a picture of it, and the piece of the art is how they figure out the fraction, decimal, percent, how many green ones are colored. They can cut this in any way. But the best part about this piece was that they pixelated it, that they used it for everything. So their model, whatever they made, they used it to learn all the transformation rules, whether it goes slides, rotates, it became their model for everything. Then they got to dilate them to make it really big for these students, which was really good. So this is the smaller image, and this is them making the much larger version of it. And I just had them lining all outside of my classroom, all the really big pieces. So like it just was really useful. They were able to create all these giant images all around the room where they were able to use it. So that was just a really good way. Like if they're into art, make connections to art. How can we do this? Okay, so that's just like a little bit of intro of things I've done. So these are 4 choices that you have to do one of these for moving forward. The interdisciplinary activity, chronological, multicultural, art enhancement, media and social media. So the first one is basically STEM, creating it to science, technology, but I also have arts and other pieces. This is like basically like a history. This one is the arts, and there's a bunch of different types of arts. And this is if we want to make connections to media and social media. So I'll go through these. I'm going to have a video really in depth about them, but I just wanted to break down some of these ideas first, for you can see how to make connections with the mathematics. So math and science are usually linked. We've got stoichiometry, distances from Earth, kinematics, acceleration, particle motion, population growth. So these are all connected. So mathematics is one of the parts of science, technology, engineering, and mathematics. They also have STEAM, which arts is in. So all these pieces are really cool, just like how we can make these connections. So this is how we can help with the English language arts. I do vocabulary quizzes every week when I was teaching math, and my students found it would really helpful, super helpful for them. So you can combine this with arts, sciences, and really make these connections. So, and another way is to focus on elements of good teaching. So it doesn't exist in a vacuum. A lot of times when I'm teaching, I always give the historical context because that helps my students to really understand where the math comes from. So if they understand where the math comes from and who creates it, they have a better idea of what it means, of like what the mathematics means. So I think it's really useful. I have them do a lot of writing, so I always have them use proper spelling, diction, syntax. You understand how many times now I tell my students they can't use contractions like can't or won't or I'm without using quoted dialogue because it should be properly I am. So I'm always using these English language rules or understanding pieces about science just to make everything feel like it's one piece. I had my students create storybooks and problems in their own words for their content standards. You can create large timelines, historical figures around the room. There's all these ways to connect it. So, and what is interdisciplinary learning? This is the big piece. It focuses on utilizing different content cogs to develop student learning in tandem. So to do interdisciplinary work, it should have a reading, experimental, or historical background to engage in the mathematical content. So this is just basically how to make these connections. So if you want to do this one, and I'll go more in depth when I just cover this one, I'm going to do a video for each of them. But basically, you take a grading content math standard, and then you have to put in English standard. So you have to put in one ELA standard to help. You have to put in one history standard to help. So are you going to have work on reading, writing, speaking? Are you going to have historical reading, biography? You're going to have to put in science standards, some sort of experimental or hands-on learning. And you reflect on it. So you get to make your own lesson with one of these three pieces. I just did English, history, and science, but I think it'd be really useful. So they can all connect. A good lesson's a good lesson. You can teach an English standard, a math standard, a science standard, a history standard all at the same time. So I think it's really useful. All right, so this is the chronological mathematics. So I came up with this pedagogical approach, and this is just something that I've created and I've tested. I've found that the best way for me to teach math is to use the history of it. So if we just have solve for x, 3x plus 8 equals 2, there's no context to that. So students don't really know what they're doing, why they're doing it, and they won't be able to get the right answer. So this chronological mathematics is to build context. And to me, building context creates connections. So I use elements from the past, the historical contribution from different cultures, primary sources. So I use the past. So basically, every concept I teach about the history where the math comes from. I do the present. So what current jobs are using the math? So the past, like who made it and why they made it. Present and current jobs using it, current technology, current media. And then the future piece is using innovations or open-ended problems, having them come up with new ways to do the math, figure out alternative uses for the formulas. So students seem to really like this idea. And then I go more in depth about it. And I believe it really helps build students' math identity. The past is like their self-concept, how they see themselves. The present, they see the general utility and value. And the future is just like their interest about it. And this one is you create an activity where you use the past, present, and future. Okay. Now, art enhancement integration. This one is big. I use the arts all the time. I'm not the best artist, but I think it's great. So enhancement is like this piece. And I've done this all the time because sometimes I can't make logarithms exciting for students. So they got to make a creepy clown or a powerful pumpkin. Notice that each answer choice was one or the other, right? So if they think it's 32, it's that type of face. If it's 8, it's this type of face. If they think the answer is 4, it's this mouth. 1/3 this mouth. And guess what? I would put the crazy pictures all over the room. And yeah, students seem to really get a kick out of it. Um, so that's enhancement or the creating the pixelated image. Now, if you want to do arts integration, you're actually teaching an art standard along with it. So if I'm teaching about tessellations, I'm also teaching students about who made them and why. What is a tessellation? This is the math standard for how to make the 3 tessellations. But I also have to not just teach them about the mathematics, but I got to teach them about MC Escher and the art standard itself of tessellation and what it actually means. It's like actually doing an art standard and a math standard at the same time. So that's art integration versus art enhancement. Okay. And for this one, you get to do, if you wanted to do this project, you would get to do a math standard, and then you would have to, and you'd have to do an arts enhancement. So basically you would do an arts activity, but also you got to pick, integrate and teach them another standard. So whether it was a dance standard, a media standard, a music standard, a theater standard, or a visual arts standard, you would get to combine that with the math standard when you create your lesson. So I think that'd be really interesting to do if you wanted to do one. I give you a bunch of different things for how to make it well done, and then you reflect on it. And the last one is media and social media. I gave this one its own because I think it's so big for youth today, media and social media. So media itself puts math in such a negative light. They say math is stupid, math is hard, people are nerds. They think of it as like these cold scientists with crazy hair who are just different from the world. And they think of math as some like unaccessible piece, right? And I just show you like all of the problems in math. Like there's all these errors and things like the Wizard of Oz, and there's parts of like number files and all these shows, and even in Popeye, right? Even Popeye. So Popeye, the only reason why people think spinach makes you stronger is because there was an error by Eric Ron Wolf that said that the spinach was 35 milligrams of iron instead of 3.5 milligrams. And if it had 35 milligrams of iron, it'd be like literally eating coins, okay, before doing it. But we still think spinach makes you strong. So there's all these errors in math, and we can really use media and social media to help us out. So I think this would be really good. So I have Yummy Math, which is just all news articles, which I think is really nice. And we have all these pieces and all these posts. I think they changed it, and now you have to pay for it. There was a time when you didn't have to pay for any of them. That was a long time ago. So they just use like current articles and current things just based on whatever's going on today, which I think is really cool. World Cup, critic, things about Pi for Pi Day, just lots of current articles. They have stuff on Super Bowls and movie theaters. I like media format a lot. It just has different things about videos that you can use and Earth stories. Then we've got stuff like radical math, which is to use stuff that has to do with social justice. So these are all different pieces, and there's all these different avenues. There's YouTubers that do such a great job teaching it. And then I go into like positives and negatives for like media and social media, And I'll go more in depth if you want to do this one. But the reason why I like this one is that there's an article about a dime heist where these people try to steal an armored truck. A truck filled with $200,000 worth of dimes but all their bags broke because they didn't realize how heavy it would be. And so there's a lesson that goes along with it where you can figure out which coins would be the best to steal based on their weight. This one is a video from Donald Duck playing pool. So you get to show students Donald Duck playing pool. And then they get to do a worksheet, and I'll show you how to do the worksheet where you actually get to see where to shoot the pool ball to make it go in the pockets. And there's two more. So this one is architecture. But I'll go through more. If you're interested in the one to do with media, if you're curious about how every job has math in it, every future job has math in it, or this movie about Srinivasa Ramanujan, who like created this movie, and then they get to do an activity. So if you want to do that one, you can watch the video on it, or if you're just interested in it, you can learn more about it. But I think using media is really important. But for your test, for your licensure test itself, when they're saying making connections, they want to know English, science. It's this first one. They want to know how you can put English, science, and history together with math, right? So it's not just STEM. This one is ELA, science, history. I have the arts in here too, but this is really what they want to see for your making connections. And if you like one of these, this could be one of the ones that you do. So I hope this was useful. Just never, I think the biggest takeaway for this is to contextualize your mathematics, okay? A lot of times, here, let me pull up one more thing for you before we go, because I want to end with like one good point. So decontextualized. Maybe it's not here. I think I did this when I was doing a talk at Bonaventure. Okay, that's okay. I'll just try to explain it. So a lot of times we get a lot of times we just get this. It says simplify, and it's like you just get a bunch of stuff like this. Like every regular math piece, like or you see the word solve, right? Or you see the word simplify, solve, evaluate, and that's all you get, right? You get 2x minus 3 equals 7, right? Like if you get things like this on a math worksheet, this is decontextualized. It doesn't have any connections to it. So even if a student solves this, they don't know why they did what they did. They don't understand where it comes from. They're not sure. So even if they do memorize the steps, they do not know why they got it right. So your job, right? Your job is, in my mind, is to give them some context. Don't just make it a sphere, make it a soccer ball. Give them a situation where this happens. Give them a situation where this happens. And if you can't come up with it, because sometimes things like logarithms or cubic functions, like sometimes it's hard to do that. And that's where you can like make the variables just become something like a picture for students, or you can teach them why logarithms were created. Like John Napier, okay? He took a train for a really long time and he went all the way to figure out more about logarithms. And when he found out what logarithms could do, he could realize, he said that his life was saved. He saved half of his life because he was trying to figure out how far apart planets were from one another and how far apart all the stars were. And the only way they could do was how to get rid of the exponents was guessing and checking and lots of mathematics. Logarithms change that. Logarithms is an ability to, if we have something like 5x equals, I don't know, 525, a log can get rid of that x without us guessing and checking to see what goes. If I have 3x minus 2 equals 3, but for some really long equation to figure out distance between planets, we can use a log to get rid of that. So sometimes it's just really helpful to either give them a situation, give them context, or explain where it comes from. So I think that's the major point I'm trying to make with this idea. And if you have more questions, or if one of these ideas were like interesting to you, I would try it, right? Do one of these for your assignment. And I'm going to make a video for each of them where I go through all the parts and all the directions. So good luck. The next one's going to be lesson planning. And I hope this first part was interesting, because right now in your course, you can see that we've done everything that has to do with curriculum, so you get to do your first assignment. Then I'll have all these, so you get to pick which one out of the ones below. So I hope this was useful, and enjoy your day.